Today's lesson, we'll be talking about solving linear systems of equations algebraically using the substitution method. So last two lessons, we have been talking about using the graphing method. So basically we put our equations into y equals mx plus b, and then we graph them and see where they intersect if they do intersect. So remember, whenever we find a solution to a linear equations, systems of linear equations, we are always trying to find a coordinate. All right? So today we're going to be talking again about the substitution method. We'll be doing 2 lessons on the substitution method. Okay, so when you have the substitution method, the thing that you are looking for is you are trying to look for a coefficient of 1. Now we have a couple coefficients of 1 throughout both of these equations, but if you see, this first equation is already solved for one of the variables, so this is what we're going to use to substitute. So what I mean by that is, since y is the same as 2x, we can replace the y in the second equation with 2x. So that's what we did right here. So we took this from the first equation and put that into the second equation. This is no different than if I told you that y equals 4, and I would have you substitute this into the equation. All right? So all I'm saying is y is equal to 2x. So this is what we're going to put into the other equation. So what you notice is when we do that, all of my y's are gone. So now I just have a simple equation that just has one variable in it. And that's really all you can solve for at one time, is one variable. So once we do that, you see that it becomes a nice, easy one variable equation. So we get that x equals 7. Now remember, I told you that the solution has to be a coordinate, because this is where both of the equations, we have a solution that satisfies both of the equations. So this means where they intersect. So once you do that, then you do just regular substitution in order to find your y value. So all that you do for that is you take your x value and you substitute it in. Now it doesn't matter which of the two you choose to do, as long as you choose one of them. I usually try to do the easiest one, so y equals 2x is a little bit simpler than x plus y equals 21, so that's really up to you which one you want to choose. And then of course we have a simple check. Okay, so on the next page what I have for you is a step-by-step procedure of how you would do how you would solve a linear system using substitution. So these step-by-steps, they work every single time. So what you're going to do, the first thing you have to do, and we'll do some equations like this. This was already done for us in example number 1, but we need to get one of the variables isolated. Okay. Now usually we do y equals mx plus b. Okay. I don't want you to only solely do this, because sometimes it'll be easier to get x by itself first. So we'll do a couple questions just like that as well. All right. So as you can see, question number 2 already is already solved for x. So what we're going to do for this one is I'm actually going to take my 4y, and I'm going to substitute it in everywhere I see an x. Okay, get rid of this red. Okay, so what I'm going to do is I'm going to do 2 times 4y plus 3y equals 22. So again, you know that you've done this correctly is if when you substitute, you only have one variable, which is what we have. So I get 8y plus 3y is equal to 22. 11y equals 22. So again, it becomes a very easy equation to solve. There's a lot of room for error in these, so please make sure that you are taking your time. And again, it is helpful to check your answers. Okay, so then what you're going to do is you're just going to substitute this back in. Okay, so I always choose the simplest one. So I get x equals 8. So the last thing you're going to do is just please make sure that you always write down your final answer. So my final answer is 8, 2. Now here's the other thing to remember, okay? We always are going to write our coordinate xy, right? So just because I found y first, be careful that you don't write 2, 8. Okay. And then you can see here that it's a little check. Okay, so far we've only done variables, we've only done systems that have an x and a y. So I wanted to point out that if you get an equation that has different variables than an x and a y, when you give your final answer, you're always going to give your final answer in alphabetical order. Okay, this is important because this is all you're giving me as a solution. Now, of course, I'm going to see all of your work, but again, we're working towards a region, so if you get a question like this on the region, they're looking for you to give the coordinate in alphabetical order. So what I'm looking here, now this one we have to do a little bit more work, so what I'm looking for here is I'm looking for coefficients of 1. So I'm going to solve this equation. It doesn't matter if you solve it for a and b, since they both have a coefficient of 1, but I'm just going to solve for a. And you would get the same exact thing for both of them. So I'm just going to subtract b. So a equals 11 minus b. Now again, the purpose of this, we take this and we substitute it in for our other equation. So I get 3 times 11 minus b minus 2b equals 8. So we're going to distribute this in, and I get 33 minus 3b. Please be careful that you guys are substituting this incorrectly. All right, and I get 33 minus, make sure that you combine your like terms correctly, minus 5b equals 8. Subtract my 33 over. Negative 5b equals negative 25. So b equals positive 5. All right, and then remember, after we do that, we have to substitute that back in. So I'm going to substitute b equals 5. I think this equation is the easiest. So a plus b equals 11. And again, it doesn't matter which one you choose to substitute it in. You get the same answer. Because what we are essentially trying to find is the solution for both of these equations. Again, we call that the intersection point. Okay, so my final answer, remember we always have to give it in the form of an ordered pair. So my solution, my solution is going to be, in alphabetical order, 6, 5. Okay, so that's my final answer. And there's the check. Remember, when you're doing the check, we have a system of equations, so you need to do both of them. All right, question number 4. So far, all of our answers have been, the first equation is the one we're solving for first. This one, I notice my coefficient of 1 is in the second one. So I'm going to solve that. I'll just do it underneath. Okay, I'm going to solve this for m. So I'm going to add 9 to both sides. So I get m equals 2n plus 9. So I'm going to take this, and I'm going to substitute it into my other equation. So I get 3 times 2n plus 9 minus 2n equals 11. Again, the biggest error you guys are going to have is when you do your distribution. So just be careful that you are taking your time with that. So I see I have a 6n, and I'm subtracting a 2n, so I need to combine like terms, and I'll get 4n plus 27 equals 11. Subtract 27 from both sides. And I get 4n equals negative 16. So n equals negative 4. You're going to go ahead and substitute this in. Remember, if you guys are fast forwarding through, make sure that you're noticing the order that I'm solving these in, or else it's not going to make any sense. Okay, so m minus 9 equals 2 times negative 4. M minus 9 equals negative 8. Add 9 to both sides. M equals 1. Okay, so again, be careful when you're writing your final answer. Okay, say the whole alphabet if you have to. M comes before n. So my final answer is 1, negative 4. This is my solution. This is my final solution. Okay? And there's the check. Oh, just kidding. That one didn't say the check. All right, number 5. Okay, so for this one, unfortunately, we are going to have to work with fractions, our favorite. So I am going to solve this one for x. Okay, so if you're using substitution and none of your coefficients are a 1, then you need to make your best judgment. So I get 3 halves y. All right, again, this is our new x value. So I'm going to substitute that in. Different color. Okay, so I get 4 times 3 halves y minus 3y equals 12. Okay, so I'm going to substitute that in. So that's basically like saying 4 over 1 times 3 halves. So 4 times 3 is 12, all over 2, so that is 6y minus 3y equals 12. Combine like terms. So even though at some point I did get a fraction, we did end up with just a regular answer, an integer. Okay, and then you're just going to substitute that back in. I'm going to use the first equation. That one's a little easier. So x equals 6, and so my final solution is 6, 4. Okay, so I'm going to move this along a little faster. I did these in advance, of course. So what I want to show you, again, sometimes they are going to be in y equals mx plus b. Later on in the chapter, I'm going to do a day where you guys have to figure out which method, which of the 3 methods is going to be easiest. If you do see y equals mx plus b, usually I tell you to graph it. But see this one? If we solve that, we're definitely for y, we're definitely going to get fractions. So for this one, again, substitution is going to be the best way to go. So if you look what I did here, okay, I substituted this in for y. Okay, don't forget to distribute, combine like terms, and I solved for x. After I find my x, I substitute that back in, and I get y equals 5. Remember, when you do your check, we should always have 2 checks, because we have 2 equations. So make sure you do 2 checks. Okay, for the next one, again, same thing. And you didn't have to do a check for this one. So I see that we have a coefficient of 1, so this is the one that I would solve for. Okay, so once you solve for that, all right, and let me point some things out for this. Okay, so we solved for x right here, and this is the first equation. So this is, this is the second equation. Okay, so we saw that there is a coefficient of 1 in front, so that's why we solved for that. So this equation becomes x equals 2 minus 2y. So I substitute that into the first equation. And again, once you find your solution for whatever variable you solved for, always put it back in. And don't forget to put it in alphabetical order. Again, we have x and y's, so that's a little easy. We know that x always comes first. Otherwise, you're going to set it up algebraically, or alphabetically, sorry. Yes, all of these are algebraic. All right, so we have another example where we are going to have a fraction. Now, the thing about, and this kind of makes this a little bit more difficult, but there's not only one way to solve these equations. There's definitely an easiest way, but there's not just one way. So I noticed that this is definitely a less complicated equation. So I would definitely solve for this one, but again, we're going to get fractions. So once you solve for that one, if you're getting the hang of this, I would recommend trying to do these by yourself. Okay, so once we get the hang of this, this really should be very easy. It's all just algebra. Okay, so as you see, we solved the first one for y, right down here. All right, so we get negative 0.75. So if you want to leave it as a fraction, that's fine, but I also want you to see that if you would rather, now I know that most of you are going to throw this into your calculator when you are solving, every little step of the way. So if you don't want to leave it as negative 3/4, by all means, please change it. Okay, you can do decimals. I'm okay with that. Okay, and then what you're going to do is you solve for your x, and then you need to solve for the other variable. So we get x equals negative 4, and then when we substitute that back in, we get y equals 3. So negative 4, 3 is our solution. And then don't forget to do a check. Okay, and for our last one, we do have another example that has A's and B's. So don't forget that we are always going to write our solution alphabetically. So for this one, when you find your final answer, again, needs to be A, B. I see a coefficient in front of this 1, so I'm definitely going to solve for the first equation. So when I solve for the first equation, here's what I get. Okay, so again, solve for one of the equations and then substitute this in for the other. So we took this and substituted into these to your A value, solve for B. Remember, you don't have to solve A before B or B before A or X before Y, Y before X. It doesn't matter. Whichever one is the easiest, do that one first. Okay, so we get B equals negative 3. Substitute that back in to one of the other equations, and your final solution is negative 8, negative 3. And don't forget to check if the directions say. All right, so that was solving systems of equations using the substitution method. So if I ever ask you to do this algebraically, you must choose one of two methods. Next lesson, we will learn the other method. Thank you.